I just want you to copy the things that jump out at you that seem or sound important that you feel you need to remember, okay? So today we're talking about key actions. Key actions are the reason that we use certain operations in math, okay? Every action has a consequence, all right? And that's what we're going to talk about today with problem solving. Key actions pertain to problem solving in mathematics. When you are reading a word problem, you need to be able to picture in your head what exactly is happening, okay? What action is happening, all right? And it's very important to know that every single action has a consequence, okay? Does that make sense? So, for example, a bad example, but if I walked up to a small child and kicked them really hard in the shin, the consequence is going to be what for that child? What's that child going to do? Cry. So that's a consequence, right? And I'm going to get in trouble, apparently. Obviously, right? But every action has a consequence, all right? So let's talk about key actions, all right? So why do I teach key actions? Well, it stresses the concept development rather than memorization of key words. I will tell you right now, first and foremost, that your elementary teachers, and I was one of them, we used to teach those key words. Okay, boys and girls, if you hear all together, we're going to add. If you hear more than, less than, greater than, you're going to subtract, right? If you hear in all, you're automatically going to add, right? Well, I will tell you right now, the state of Texas has gotten very, very strict about that. Thank you. And they have learned to change the wording to trick you as a student. So now I like to teach an action instead of those key words. I want you to hone in on those key actions. What is happening in that problem, all right? An action provides a reason for an operation, okay? If I put things together, if I take that group and put it with this group, what's happening to my group? It's getting bigger, right? And the action, the consequence of getting bigger is I add, right? I added, I made them bigger, okay? All actions have consequences. No matter what I do, there's a consequence, okay? It builds from a concept level through an abstract level. And we use visual clues until students become proficient in identifying the action and word problems. We're getting away from those key words. I don't want you to memorize key words. Now I say that, but later on in my presentation, there is one word. There's one word that I feel very strongly about, and I will get to that in just a little bit, okay? So it aids you in solving most routine problems, including those you'll see on the star. Not tacked, it's old. All right, so first one, top of your paper is what key action? Put together, okay? Now, I don't want you to think about the words. Think about the action of putting things together. If I put this group of students with that group of students, what happens to my group of students? It gets bigger, all right? The action of putting things together is the reason that I do what? I add. I take this group of 6 students, I put it with that group of 4 students, I add them to get a group of 10 students, all right? So result in a larger amount than what I started with. Okay, remember, we're taking notes right now, focus notes, writing down things that jump out at me, okay? You're not copying word for word what's on the board. You will not have time for that. Just copy down words or phrases really quickly that stand out and you feel are important that you think you might need to remember, okay? All right. So joining or putting together involves an action in which a set is or are increased by a certain amount, okay? And that result is unknown until I do the operation. I don't know the result until I do the math, right? So it looks something like this. I saw 3 butterflies on a flower. Then 2 more butterflies appeared on the flower. How many butterflies are now on the flower? Did you hear in all? No. Did you hear all together? No. Did you hear total? No. Ah, but what kind of problem do you think this is? It is addition. Even though I didn't hear those key words that us elementary teachers love to teach, it's still addition. There are my 3 butterflies. 2 more appeared on the flower. How many butterflies are now on the flower?
5.
5. Okay. What was the action?
Addition.
No, that is the operation. What's the action? Joining or putting things together. Okay. All right. The next one we have is takeaway. All right. Now, takeaway is the most common reason that we subtract. When I am taking things away, what happens to my original group? It gets smaller. Good word. Not lesser, but it gets smaller. Yes, it gets smaller. right? Something is removed, it's used, it's spent, etc. Okay? If I keep sharpening my pencil, eventually my pencil is going to go away, right? All right, it gets used. Result in a smaller amount than we started with. All right, so this is the most common form of subtraction. If you are removing something from the set, you are using subtraction. So let's look at this one. There were 5 turtles sitting on the beach. 2 of the turtles decided to go for a swim. How many turtles are now on that beach? All right, so let's look at this. There are my 5 turtles. They're hanging out on the beach. 2 of them decided it's way too hot. I'm going to take a dip in the water. How many turtles are now on the beach? 3. Did you hear? Left over. How many are left? Okay, those key words don't work, do they? You have to think about the action. I had 5, 2 of them went away. So I took them away. When I take something away, I subtract. Okay, so far so good? All right, moving right along. This is the one I love most. This is probably my favorite reason for subtraction. When I compare 2 things. When I compare 2 things, I'm looking for the difference. And the difference is the answer to a subtraction question, right? So if I asked a very tall student to stand next to one of my short students, could you see a difference in their height?
Yes.
Absolutely. If I'm looking for a difference, I subtract. Some things when you're comparing how much more something is, how much less something is, how much taller or wider or fewer, things like that. When I'm comparing 2 things, I want to find a difference. Alright, the difference between the 2 should be less than either of the sets. Well, that makes perfect sense. If one student is 5 feet tall and one student is 4 feet tall, what is the difference?
The height.
What is the difference in their height? 1 foot, right? Is 1 less than 5?
Yeah.
Is 1 less than 4?
Yeah.
Yeah, so the difference should be less than either of the 2 sets. Okay? Now let's see what this one looks like. I really like this visual here. Okay? And of course it results in a smaller amount. Alright, so there are 5 cats sitting on a fence. 3 dogs are trotting by the cats. How many more cats are there than dogs? Well, let's look at that. 1, 2, 3, 4, 5 stinky cats. And 1, 2, 3 pretty dogs. Are there more cats than dogs? It's obvious, right? So I can see a difference in the number of cats and the difference in number of dogs, correct? So what is the difference in the number of cats and dogs?
There's 2 more
2.
cats.
There are 2 more cats. Very good. Alright, 2 more cats. Okay? And the last one. Now I will tell you right now, boys and girls, that if you did not learn how to use a strip diagram last year or the year before in 3rd and 4th grade, you are significantly deficient. A strip diagram is one of the most effective tools an intermediate and elementary student should have in their tool bag. A strip diagram can be used to answer any multiplication, division, addition, or subtraction problem. You might know it as part, whole. Okay? Part, whole is where I have a whole and I have a part and I'm looking for the missing part. Okay? I take the whole, I subtract one of the parts, and I find that missing part. Alright? And it is also a reason that we subtract. Okay? Sometimes seen as a missing add-in problem as well. And it always results in a smaller amount or a less amount than the whole. Okay? Here's a good example. At a table where there are 4 boys and 2 girls. Okay? There are 6 students total. 2 of them are girls. What is the whole? 6 students. Very good. What part do I know? 2 of them are girls. How would I find the missing part or the number of boys? Subtract the whole 6 students minus the 2 girls to give me my 4 boys, the missing part. Alright, so let's look at that in a word problem. Justin has 12 marbles in his collection. There are 8 red marbles. How many marbles are not red? Well, here's Justin and his marbles. I like Justin as his tongue hanging out. He's having a good time there at this marble collection. Okay? There are 12 marbles. Some of them are red, some are green, correct? I take away the 8 red ones. How many are not red?
4.
4. The missing part is 4 marbles. That make sense? The whole was 12, and the 2 parts are 8 and 4. Alright, now let's get you some 5th grade stuff. 5th grade stuff. Put together equal sets. Alright, so now put your pencils down. We are no longer taking notes on these 2 pages. Put your pencil in your book, close your book, and just listen to the key actions here. Okay? No longer taking notes on this part. So multiplication, put together equal sets. A set contains the same number of items. That means every group has to have the same number of items in each group. That make sense? I cannot multiply if my groups do not have the same amount in each group. We knew it as repeated addition. Okay, now remember, mathematicians can be lazy by nature because we're always looking for a shortcut. Would I rather add 13 plus 13 plus 13 plus 13 plus 13 plus 13, or as a mathematician, would I rather multiply 13 times 6?
13.
Absolutely, it's a shortcut, right? It's easier. It results in a quantity greater than the number in the sets. Let's take a look at that. Luke has 5 groups of 4 cars. How many cars are in each group? 4. The same number of cars in every single group, right? It has to be that way. My question is, how many cars are there? Well, here are his 5 groups. And he puts how many cars in each group?
4.
4 cars in that group, in that group, in that group, in that group, and in that group. Now, how would I find how many cars there are in all? I multiply the number of groups, 1, 2, 3, 4, 5, times 4, the number of cars in each group, to give me 20 cars. Alright, now here's one we don't see very often. I don't normally teach it, but I think it's important for you to listen and hear it, okay? This is arrange in rows and columns. It's very, very similar to the previous groups, except the groups are in a very specific arrangement, and that is a row of columns. We know it as an array. Okay, you learned an array in 4th grade. So the similar to equal sets, but the items are in rows and columns. It is also still repeated addition, and the quantity, the result, is still larger than the initial. Okay. So Luke has 4 rows of cars. Each row has 4 cars. I'm sorry. Luke has 5 rows of cars. Each row has 4 cars. How many cars are in his collection? Now this is kind of like shelves. How many bookshelves do you see? 5. Bookshelves are kind of like rows. And he puts 4 cars in each row. Now I have columns. 1, 2, 3, 4 columns. And how many are in each column? 1, 2, 3, 4, 5. So if I look at it from an array approach, the number of rows, 5, times the number of columns, 4, still gives me 20 cars. Does that make sense?
Yep.
You'll see this kind of question when they talk about bookshelves and things like that. Alright? Okay, now let's get into division. The first red card in your journal today. Share a set equally. I talked about this last week. Remember when I talked about playing the card game? Where you start with a big deck of cards and you pass all those cards out until what happens? All the cards are gone and everybody should have the same amount of cards. So I'm taking a set of cards and I'm sharing them equally amongst a certain number of people. Does that make sense? Alright, so this is what it looks like. This type of division involves putting items in a set number of groups. So if I have 5 people playing the card game and I have 50 cards, I pass out all 50 cards until every card is done. Gone, correct? You know how many groups. I also know how many I started with, but what don't I know? How many are in each group? Very good. I don't know how many are in each group. Okay, now this is where I pause for a second and I ask you to take caution in what I'm about to tell you. I don't teach key words, boys and girls. I don't believe in key words. I firmly believe in key actions. However, there's one word. There's one word that I've yet to find a conflict with, and that is the word each. If you come across the word each, and it is written in the question sentence, for example, how many fish were in each bowl? How many students were in each class? How many pencils did each student get? If the word each exists in the question sentence, it's going to be a division problem. 99.9999% of the time. I've never seen it. where it was not a division question. Okay? Now, if the word each is in the problem, but not in the question sentence, that's different. Okay? Did everybody understand that? I'm not teaching you that if you see the word each, you should always divide. That's not what I'm saying. I'm saying if you see the word each in the question sentence, think about it might be a division problem. It's probably going to be a division problem. Most likely. Okay? Now, so let's talk about divvy up. Divvy up means I divide. Divvy sounds like divide, right?
Yeah.
I'm divvying up all the cards. I'm divvying up all the pencils. I'm divvying up all the pieces of candy. Okay? Alright, so let's look at that one. There are 25 pencils and 5 students will share them equally. There's that word equally again, right? It's in my key action. Share a set equally. That's also telling me a clue. This might be division. How many pencils will each student receive? Where do you see the word each? In the question sentence. Okay? It's in the question sentence. That's what it looks like. Here are my 5 kids. I'm going to take and pass out every pencil until every pencil is gone. And then count how many pencils does each of my students have. They're all gone. This student has 5, she has 5, he has 5, he has 5, she has 5. So every student has 5 pencils. I divided 25 pencils by 5 students and every child got 5 pencils. Okay? Take away equal sets. Now this is the one that appears very, very common. It's more common today than it used to be. I'm going to explain a scenario before I show you one. Okay? Imagine a giant fish aquarium. Okay? Picture a big fish aquarium. There are 48 goldfish in that fish aquarium. I want to put all 48 goldfish into groups of 4. That means I'm going to take out 4 goldfish, put them in a fish bowl. That's one bowl of 4 goldfish. How many goldfish are left? I started with 48, I took out 4. 4 left. I take 4 more goldfish, I put them in another bowl. Now I've got 2 bowls. How many goldfish are left? 40. I will keep taking away groups of 4 until all the goldfish are out of the aquarium and in what? Bowls. I'm taking away equal sets of 4. Does that make sense? I'm taking away equal sets. In this problem, what do I know? I know the whole, the number of goldfish. I also know how many are in each group. But this time, I don't know how many what? I don't know how many groups I'm going to have. I don't know how many bowls I need, do I? That's what I'm trying to figure out. How many fish bowls will I need? Does that make sense?
Yes.
Okay? So, we measure out. This kind of problem we are measuring out. So, there are 25 pencils that come in packages of 5 pencils. So what do I know? I know a total of 5 pencils. I know how many are in each package, right? Each group. What I don't know is how many groups I have. Okay? So there they are. I take a group of 5, put a bow on it. That's one group. Another 5, 2 groups. Another 5, 3 groups. Another 5, 4 groups. Another 5, 5 groups. So I took away groups of 5 and made how many groups? 5. What kind of problem was that? Division. Did you hear the word each in the problem? No. But was it still division?
Yes.
That's why I don't teach key words. But I will tell you, the word each is a very special word. I'm not telling you always divide if you hear the word each in the problem question or the question sentence. But if you see the word each in the question sentence, think it's probably going to be division. Alright? Make sense? Okay, open your journal now. Open your journal to those 4 cards, division and multiplication, and we're going to practice for a little bit. Alright? Now it's your turn. Good luck.